Hello, if you've watched my last few videos, you'll know that I recreated the Blackpool Tower photo that has been making the flat earth rounds, thanks to Ranty coming out of the flat earth community. And my take on it was to take the elevation data that was provided by NASA and to compute how it should appear for each of the data points if the Earth was a globe and or if the Earth was flat, along with projecting where the tower should appear relative to the mountains. And I showed the math that I used to do that in my last video. And I think that this is going to be a wrap up of this whole process. One of the other things that I wanted to do was to take the photograph that was taken, and I ended up grabbing this from stitching a bunch of still frames from one of Ruhif's videos back together. I don't have the original photograph, and I'm a little bit too lazy to try to find it. So I ended up taking this photograph and putting it as a separate layer to this data file in GIMP. Here was my rendered version of the Blackpool Tower photo using the Globe Earth dataset. And what I wanted to do here was to compare and overlay the rendered version on top of the photograph that was taken. And one of the things that I noticed was the aspect ratio wasn't set up properly. I don't know if it was because of all of the conversions that were taken that led up to this that I had taken from Ruhif's video. So what I did was I took this layer and I copied it, then I scaled it so that the height of this tower matched the height of this tower. I lined it up as best as I could. I created a separate layer and I marked the mountain range skyline as you see here, along with a line that marks the base and the tip of the rendered tower. And if I overlay the photograph that was taken, here you can see that it's not really an exact match, but I've already shown on a number of occasions that it is by far a lot closer than the flat earth model rendering. There are several factors involved. I'm assuming a uniform 7/6R refraction. I don't know what the conditions were when this photo was taken. That can explain why the tower doesn't line up exactly like it should. I copied the layer and I adjusted the colors on this one so that you could see a little bit more clearly. But I would say that this is a clear indication that the globe Earth model matches reality and the flat Earth model does not. But finally, I would like to show a couple of animations that I did. The first is the globe Earth model, and you'll see at some point very shortly I changed the labels. Although the rendering remained the same, I didn't feel like going back and starting over just to re-render these frames with updated text. I start off with the standard view that you see in the Blackpool Tower photo that's been making those rounds. Then I zoom out. Then I start a 360-degree rotate around all of the land that is seen in that photograph. Here you can see that I already switched the labels around. After I reached the 360-degree mark, then I thought I was going to try something else as an experiment. First, I get the camera to descend to 500 meters below its current level. At some point, I get the water to descend to 500 meters below its current level as well, but at a faster rate than the camera because the camera had a head start. Here, the camera is now below the surface of the water, and just ignore these artifacts. They are objects that I created so that if I don't render the water, you get a seamless blending of white sky below your horizontal level and the blue gradient above. So these are a couple of different objects that I had created in order to create a seamless background when I decided not to render the water. And so here you can see that now the water is below the camera. and we continue to descend. When they both reach 500 meters below their initial values, then I zoom the camera back in, and then I start going around 12 times, raising both the camera and the water back to zero. So you get these 360-degree turns. When it reaches zero again, then I switch the water from the spherical model to the flat Earth model. So then you'll see that the water is kind of like the surface of a large box. So there's the water is now flat. And as I start rotating around to 90 degrees, I'm rapidly dropping the camera and the water level again. Here you can see the water is flat, but the land is curved, and then at 500 meters below their initial starting points, as I complete the first and I do the other 11 loops around, I raise the water level again. Finally, to complete it, just to disorient you, when I reach the starting point again, I now go in the other direction, lowering the water back to 500 meters below and zooming out at the same time. And so here you can see there's a far greater gap here than there is between the tops of these mountains and the surface of the water for a globe Earth with flat water, when the opposite should be true. This is very close to mean sea level. This is more like 800 meters above mean sea level, and yet this is closer to the water than this. And then whenever I get back to zero, I zoom back in. You'll see that the camera is moving up at twice the rate as the water. So when the water reaches zero, the camera will now be 500 meters above where it was from the beginning. And here, just for a brief moment, you can see that when the water level reaches where it's supposed to be on a flat Earth, the land would be underwater. And here I switch back to the globe water model and I drop the camera again. I do the same thing for the flat Earth. Here I do the exact same rotation and water level adjustment for the flat Earth. The primary difference, I start off with flat land and flat water. Then halfway through, I switch from flat water to globe water. And here you can see that it instantly changes the gap between the land and the water. Then I do my spin arounds, and then at the very end, when I come back up, you can clearly see the gap between where the water is and where the water should meet the ground. And then I switch back to the flat water model, which now moves the water back to meet the land. And then I lower the camera, and that's the end of that video. I'm going to include the full video's first globe Earth model here. then the flat Earth model here. And that's going to be it for this video. Thank you for watching. Once again, if you like this video, I would appreciate the subscribe, the thumbs up, the comment below, all that other good stuff. And I'm going to see you in another video soon enough. So bye for now.